So, here's what we're doing in this section. We're going to write equations of linear functions. So we'll write equations of what?
Linear functions?
Yeah, but what are linear functions? Lines, right? Straight lines. Which we've already done that little bit of that, right? We did something called y equals mx plus b, which is what? Slope-intercept form, right? We also did point-slope form, right? But the way I like to do stuff is using slope-intercept, so that's how I'm going to go over stuff. And we're going to do some word problems, okay? And we're going to do something called the line of best fit, okay? So that's what what this section is about, and it's not too bad, really. Make sure you have that graphing calculator tomorrow, because the graphing calculator is going to help you do these types of problems tomorrow. Today we're going to do them the old-fashioned way, like I used to have to do them when I was in high school. Okay? But tomorrow we'll use our graphing calculator to help us get through this stuff. So here's what our problems look like. Some of them. It says the graph shows a distance asteroid 2019 GC6 travels in X seconds. It says write an equation of the line and interpret the slope. Okay? So let's talk about slope. We talk about rise over run, right? We talked about that earlier this year. Rise is which direction? Up or down, right? This way, which is which axis? The y-axis, right? And run is which way? Left and right, which is which axis? The x-axis. Okay? So, to figure out the slope, we figure out how much it's moved vertically, the y's, and how much it moves horizontally, the x's. And we write that fraction. Okay? And the symbol we use for slope is m. Remember? When we put it in slope-intercept form, m's our slope, right? What's our b? The y-intercept. Thank you, Haley. You guys remember that, right? We did a little bit of that at the beginning of the year, a few weeks ago. Okay, so we're going to write the equation of this line that we see on this graph in slope-intercept form. Okay? So that's the first thing. We're going to write that equation. Then we're going to interpret the slope according to this. Okay? And then we'll answer this question. How long does it take the asteroid to travel 136,000 miles? So we're going to do all of that. Okay? So, let's do the B part first. What's B equal for this problem? Look at your graph. It's 0, right? Remember, y-intercept is where the line crosses the x-axis, right? No, I lied. The y-axis, sorry. And the x-intercept is where the line would cross the x-axis, right? So, from our picture, from our graph, we can see that it crosses the y-axis at 0, 0, so my b is 0. Okay? Now let's figure out our m. If we start from here, how far do we rise to get to that point? How far did I rise? Up. What does it say? 21, right? How far did I run? 6. You see that? From that point, since we have one of our points is 0, 0, whatever the y value is my rise, and whatever the x value is of the other point is my run. That make sense to you? Okay. So, substituting in to our slope-intercept form, we can write y equals, what's that reduced to?
7 over 6.
Right, divide both by 3, right?
Yeah.
So I can substitute 7/2 in for the m, and then x, and then what for the b? 0, right? Do I need to write the 0? No, we don't really have to write it. So we can just write our equation like that. If you want, what is 7 divided by 2? 3.5, right? So if you wanted to use the decimal, you could. All right, so again, we can figure that equation just by looking at our graph. Questions on writing the equation. Does that make sense? Now's the time to ask. We're good? You guys are so smart. A lot of you guys were second guessing yourselves, I think, yesterday on the quiz. Go with your gut. All right. So our slope, it says here, write an equation. So we got that part. It says interpret the slope. Okay? So our slope is 3.5, right? Or 7/2. All right, look at what this is a picture of. This graph is a picture of this asteroid. The y is representing what? Distance or miles. And the x is representing time in seconds, right? So remember, rise y over run x, that means miles per second. So the slope means the asteroid travels 3.5 miles in the top per second in the bottom, right? You know what that's telling us? That's pretty fast, isn't it?
No, it's kind of slow.
All right, so just to give you a little bit of perspective, 60 miles an hour is 1 mile per minute, right?
Oh.
Okay, and 60 is pretty fast in a car, right?
Yeah.
All right? It's pretty fast. It's not real fast, but it's pretty fast. This is 3.5 miles in 1 second. All right? So we interpreted our slope, okay?
No.
All right, so it says here the second part. We're looking for how long does it take the asteroid to travel, and it told us that. It got 136,000 miles close to Earth. It never really got any closer than that. But probably it was something we could see from, just looking up if it was dark out, I guess. All right, so how long does it take this asteroid to travel 136,000 miles? Okay, so where would I put that 136? Would that be the x? Or would that be the y? Remember, miles. Is miles the x or the y?
Why?
The y. Okay, looking at your graph, right? The y is the miles. So we're going to substitute to answer this part of it. 136 in for y. We'll just use the 3.5 for our slope. So how do I solve for x? Just divide by 3.5, right? Okay, so when I get this answer, which was 38,857.1. What's that time? You got your picture. What's the time? seconds. Do we usually answer questions like this in seconds?
No.
Usually in what? Minutes or hours, right? So let's answer this in hours. How do I figure out how many hours that is? Divide by 60? How many? Is there only 60 seconds in an hour? No, that's 60 seconds in a minute. How many minutes in an hour? Yeah. Say that again.
3,600.
Right, 60 times 60, right? So we want to divide that by, if we want to see how many hours that is, we're going to go 38,857 divided by 3,600, which is 10.8. So we're taking about 10.8 hours to go 136,000 miles. Does that make sense? So the process we did to get our answers? All right, we looked at our picture, our graph to figure out our slope, and we looked at our picture to figure out our y-intercept. And we substituted into our y equals mx plus b form, slope-intercept form, to get our equation. Any questions? And then we just answered questions, what we were supposed to answer. Ellie, you all right? Sure. Okay? Again, just take your time. All right? I would use graph paper to do this kind of stuff. I have some up here on my desk if you need some. But you might want to get your own too, so you have it if you're at home and need to do some graphing stuff. All right? So just kind of interpreting the graph after we figured out our equation. All right? Answering questions. All right, second example. This graph shows the remaining balance y. So our y is balanced in thousands of dollars, this is, on a car loan after making X monthly payments. So these are monthly payments. Write an equation of the line and interpret the slope and y-intercept. All right, so they gave us 2 points. All right, so my M is the difference in the y values. Difference means to do what? Subtract, right. So I'm going to take the first point here, 018. Again, it's on our picture in 1050. So it's y minus y over x minus x. Just go the same direction. If you went 15 minus 18, then go 10 minus 0. Just be consistent. All right, so what's that give us? There's our slope. If you want to write the decimal, you can. Okay. And what's my b? Looking at our graph. 18, right? That's where the line crosses the y-axis, right? That's my b, the y-intercept. So if we put it in y equals mx plus b, Joe, what's my equation?
y equals negative 28x plus 18.
Right. Any questions on that? That makes sense. Pretty easy, isn't it? Isabella, you all right? Okay. Josh Boss, you all right? Yep. Good. All right. So we got our equation. Interpret the slope and the y-intercept. Okay? So minus 0.3, that's my slope, right? What's that telling me?
Sure. Well, I was looking at the X and the Y, trying to figure that out, but that's not right.
Okay. Go ahead.
Wouldn't it just be the thousands of dollars over the number of payments?
Yeah, it is, but that's our slope. So let's interpret it. What's that telling us? Think about the problem. Okay, this is a car loan. Right? Most of us don't have enough cash to pay a car, right? So we have to borrow money. So how much money did we borrow? $18,000. You understand that? That's what we borrowed. Because remember, 18, and this is in thousands of dollars. That's $18,000. Okay? Each payment, we're subtracting, right? Because it's negative. 0.3 thousands of dollars, right? So what's 0.3 times 1,000? Alex?
300.
Thanks. So the slope is telling us each payment, the balance is what? Di? Going down 300, right? Or $300 less. That make sense? Okay? You got to look at what's going on here. Understand the graph, interpreting the graph a little bit. Okay? The y-intercept, we just said that. What's the y-intercept tell us? $18,000 balance, right? Or that's how much we borrow. Okay? So far, so good? All right, there's another question that goes with this. How do I figure that out? What's the remaining balance after 36 payments? Yeah, just basically 36 times 300, right? Or just put it in our formula, right? Our equation. Whoa! So y equals, y is the balance, right? Negative 0.3 times 36, and then plus 18, right? What's that come out to? Alex, you got your calculator out, don't you?
Yeah, that's 1.2.
7.2. So all that's left is $7.20, right? Right, Robbie? Does that make sense? What do you think, Alex? Remember, what's the y in? Whoa. These numbers are in what? So, Robbie, what's 7.2 thousands of dollars? This is 7.2 thousands. So actually, how much money is that? No,
7,200.
there you go. So, 36 payments is how many years? 3 years, right? So after 3 years, you still owe $7,200. Okay? So, just understand, we're getting these littler numbers, but remember what our graph is showing us. It's in thousands of dollars. Right? So we're in between, what's this? They're going by what? 3, 6, 9, so going, so somewhere up there, we're over here, 36. Everybody's going by 5s. So we could look at 36 over here, go up and go over, and kind of guess. Right? But we have our formula or our equation, so we don't need to guess them. All right, one more question. What's the meaning of the x-intercept? Let's go back and look at the picture, the graph.
Number of inches.
Yeah. Which is how many? What is the x-intercept? 60, right? So we're going to have how many payments? 60 payments. Or how many years is that? 5 years, right? That's a 5-year loan. You buy your car yet?
No,
No. You have to share it, right? 3 ways, 2 ways? Right?
we have 2 cars.
2 cars for 3 of you?
Yeah.
Wow. Do you usually get left out?
No.
No. Liz, does she get left out?
No.
Who's the other one? Who's the other one? What's the other one's name?
Oh, Emily.
Evelyn. She gets left out. Oh, okay. Was she the youngest?
No.
Oh, you're the youngest. Oh, so the baby gets whatever she wants.
Yeah.
Yeah. Are you middle or number 1? You're the middle, huh? All right. What's the matter, Emma?
He said something. I don't know what he said.
Morrison? You being mean, Morrison?
I swear I'm not being mean.
Okay, good. I'm glad to hear that. All right. Questions? Do these 2 examples make sense as I go over them kind of slow?
Yeah,
Not at all? Ty? Ty's saying I'm a bad teacher. Okay, I understand. All right. 2 prom venues charge a rental fee plus a fee per student. The table shows the total cost in dollars for different numbers of students at Lakeside Inn. So this table is for the Lakeside Inn. The total cost Y in dollars for X students at Sunview is represented by the equation. They gave us the equation for Sunview. All right. Which venue charges less per student? Well, how much is Sunview charging per student? Robbie? Yeah, $10. All right. How do I figure out which one's charging less? What do we got to do with the Lakeside Inn? Figure out the equation, yeah. How do I figure out that equation? Looking at the table. What do I need to know? Or what I need to use? Well, how do we write the equations of the first 2 examples? What do we find first? The slope. So how am I going to find the slope? What did you say, John?
The equation?
Yeah, we want to get that's going to help us get the equation. Oh, that's the 1 equation. We're looking for the Lakeside equation. Joe?
Take an X and a Y and make it a 10.
Yeah, use 2 of those points, right? These are points, right? For 100 students, it's going to cost $1,500. For 200 students, it's going to cost $2,700. And all those in between. So we can figure out, we can use these as a point. X and our Y, right? As I was saying, our domain and our range, right? So let's just use the first 2. So what's my Y's? Just go 1,500 minus 1,800. Remember, rise is the Y's, right? Overrun the X's. So I'd go 100 minus 125. Okay? So, I get negative 300 over negative 25. What's that equal? How many quarters in $300 or $3? Brooke? How many quarters in $1? Right, so how many in $3?
No, I really am not.
Wow.
Oh, you poor, wow. 12, thank you. Yeah.
I'm paying attention, Anna.
Alex, quit being mean. Let me pick on her. All right. So, 12. So y equals 12x plus b. How do I figure out b? We don't have a picture to look at now, like we did. What? So, are you saying plug in one of the points? Okay, that's good. A good idea. Yeah, that's what we did before, isn't it?
Yeah.
When we were doing this a few weeks ago, we were using one of the points to figure out our b, right? All right, Lee, you pick the point. Which one of those points do you want to use? You got 5 choices.
Third one, 115.
Okay. And it doesn't matter which one. He said the middle one. But it doesn't, you can pick any of the 5. All right? So what goes in for x? 150.
The third one.
The third one, Mr. Farmer. And what goes in for y?
21.
21.
Oh my God, you usually about to say that you have.
Well, I just reversed the 1 into 2. It happens.
There's no excuse for that, dude.
Hey, I'm
Hey,
here
be
too.
nice to each other. Come on. All right, so what's 12 times 150, Alex? You got your calculator out? Still? 12 times 150. Oh, we got it already? Thanks.
Good job, Alex. No. I'm not gonna let it fool you.
So what's B gonna equal? 300, right? We're gonna subtract 1,800. Any problems with the work there, how I got 300? So Noel, what's my equation? Good. So there's our lakeside equation. And there is our Sunview equation. Which venue charges less per student? Here's Lakeside, Sunview. This was $10 a student. This is $12 a student. So Sunview would be less per student, right? That slope tells us how much per student. Okay? What's the other? How many students must attend for the total cost to be the same? What's the same mean? Equal, right? So what do I do to set them equal? Just 10x plus 600 equals 12x plus 300, right? That way the cost would be the same. So again, each problem's asked us to figure out of something a little bit different, but you guys should be able to, what was it, plus 600?
Yes.
Yeah. You should be able to figure out what you need to do to answer the questions. And when we solve that, how do we get over there? So I'm going to subtract 10x because 10x is smaller than 12x. I'm gonna subtract 300, since I put the x's on the right, I'm gonna take everything else to the left. So the 300s are gone, and the 10x's are gone, I get 300 equals 2x. So what's x equal? 150. So if your problem has 150 kids, it doesn't matter which one you go, it's just gonna cost you the same. Okay? Questions? All right, so line of best fit. All right, data do not always show an exact linear relationship. All right, sometimes our data doesn't make a nice straight line. All right, sometimes they're all over the place. It says when the data in a scatter plot, you guys should know what a scatter plot is. Just a bunch of plotted points, a bunch of dots, show an approximately linear relationship. You can model the data with a line of fit, or line of best fit is what we call it. Okay? So, here's how you make a line of best fit. You make a scatter plot from the data. They'll give you the data. They'll give you an XY table. It says draw the line that most closely appears to follow the trend given by the data points. Sometimes it might go this way. Sometimes it might go this way. Sometimes it might go this way, like a constant, right? There should be about as many points above the line as below it. Choose 2 points on the line and estimate the coordinates of each point. These points do not have to be original data points. You can pick any 2 points you want on the line that you drew or you draw. Then write an equation that passes through the 2 points from step 3. You might have to find your y-intercept, but my suggestion would be to draw your line long enough so that it crosses the y-axis. So then you don't have to try to figure out what your y-intercept is. Make sense? All right. So the table here shows the femur lengths, which I think is this bone in your leg up here in the thigh. It says the femur lengths in centimeters and heights in centimeters of several people. So there's a relationship between how long this bone is and how tall you actually are. All right? Does the data show a linear relationship? If so, write an equation of a line of fit and use it to estimate the height of a person whose femur is 35 centimeters long. Okay? So what you're going to do is figure out a line of best fit, write the equation of that line, and then plug 35 in for x to figure out how tall this person is. All right? So I just plot those points. Okay, I already set it up. Height was the y, femur length was x, and I set my scale. Since these were bigger numbers, I wasn't going to go by ones all the way to 50, and then by ones all the way to 200, okay? So what you can do when you draw a graph is you can kind of break the scale, kind of do something like that. That just showing that you kind of broke it and started down the line a little bit, okay? So I'm just going to plot those points then. 40 and 170. So these are going by tens, right? So 170 is there and 40's here. Okay, 45 and 183. So here's 45, there's 180, a little bit above the 180, right? Maybe I should go a little further on that, right? Because it's going, no, that'd be 190, right? Going by tens. So I'm okay. 32 and 151. So 32's, that's 32 and a half. So 151, probably about there. 50 and 195, 50, 195, about there. 37 and 162. Is it going to be a linear relationship, you think? They're looking pretty good, right? Yeah, it's going to be a linear relationship. Where are we at? 37 and 1, I did that one, didn't I? 41 and 174. So 41, 174, what's that, 170, so about there. 30 and 141. $34 and 151. $47, 185. And 45 and 182. They're about the same spot, aren't they? All right, so I want to draw a line of best fit. Again, what I would use is some straight edge. You know, maybe your calculator, or just have maybe the edge of your calculator. Maybe a ruler if you got one. And I would draw a line that best fits in there and comes all the way and crosses your y-axis, so you can use that as your y-intercept. Okay? What did it say? Try to get about as many points above the line that you draw as below it. All right? So again, ours are all going to be a little bit different, but just do the best you can. And it's kind of hard from starting back here, but I'm going to start, I don't know, about 120. Just draw it in here about like that. I got a couple above, some that are right on, and a couple below. All right? So that's, again, you might be a little bit different than me. All right. Now, how do I find my equation? Just pick 2 points. All right? So I'm going to pick 2 points on here. That one looks like it was 1, right? That was the 40, what? 170. So I'll use that one. And let's use this one here that wasn't on our, but it looks like, what's that? 47 and a half. What does it say? 47 and 190. And then from here, I do find my slope. So 190 minus 170 over 47 minus 40. You guys understand that's just what we did before, right? And then our B, we'll just use 120. Okay? So my equation, y equals, what's that? 20 over 27 x plus 120. And then go from there to finish it up. Okay? So yours might not all be exactly the same. That's okay. We're not all going to be exactly the same. But just do the best you can. Any questions? Okay. Again, bring your calculator tomorrow. Make sure you have your graphic calculator. It'll do a lot of this work for us. But I want you to be able to do it by hand in case your calculator goes bad for some reason. So there's your homework assignment. Thanks for your attention. Remember odd, 1, 3, 5, 7, 9, right?
Yeah.
What do you mean is it on canvas?
Like the slides already?
Yeah.
Okay. 42.